In this video, we look at the domain of the logarithmic function. So in another video, we not quickly actually, we spent sort of a long time, we sketched the graph of y equals log base 2 of x. And then I am going to roughly recreate that over here. And I said, although I don't know if I really said anything convincing, or I didn't do anything convincing, but I did say that if I change the base from 2 to any other positive number, the graph will look very similar in a lot of ways. The intercept will be the same, and we'll still have the same vertical asymptote. This one I'm writing as y equals ln x, and we would need a computer graph to see the difference between these two. And so recall y equals ln x is the same thing as y equals log base e of x, where e is Euler's number, and it's around 2.718. So if we look at these graphs, the domain is what? Well, domain is possible x values. So we can see from this graph, if you can believe that's true, so just believe that this is the graph, we can believe that the domain is all x such that x is greater than 0. So this is the graph, and it has points that satisfy the equation, and the x-coordinate here is positive. Over here, the x-coordinate is positive for both of those graphs. So the x-coordinate will always be positive, so we can only look at x greater than 0. So that's our starting point. And now we're going to work it on some examples. So I wrote domain. This is for y equals log base a of x when a is a positive number. Okay, so let's look at an example then, where we just find the domain of different functions relating to a logarithm. So we can look at y equals log base 2 of x plus 3. So the domain of logarithm is whatever we put inside has to be greater than 0. So what's inside here is x plus 3. So x plus 3 has to be strictly greater than 0, or x is greater than negative 3. And you can write the interval, actually I'll just write domain. I can write that in interval notation as negative 3 to infinity. You know, here it is on the number line, if that helps at all. And it's all that stuff colored to the right. So that's the interval notation, which even if you don't use it, you should understand what that means. Let's do b is log base 5 of x minus 2 all plus 1. Okay, so the solution is that we just look at that part that's the input of logarithm, and we make that greater than 0. So that makes x greater than negative 2, or you could write the same as negative 2 less than x, or just like that. And so the domain in interval notation is negative 2 to infinity. Well, we could try even more difficult problems, but we maybe don't want to overdo it. But anyway, here we go. Let's do y equals ln of 5 minus x. And so for this, we just look what's in the logarithm and we make that greater than 0. So if I subtract 5 from both sides, I get negative x is greater than negative 5. And then I multiply by negative 1, and when you multiply by negative 1, you change the direction of the inequality. Now, you don't have to do it that way. You could add x to both sides and get the same thing. But I did this wrong here, positive 5. So I multiply by negative 1. And when you multiply by negative 1, you change the direction of the inequality. You'd see get the same result if you added x to both sides. So the domain of this is from negative infinity to positive 5.